So for my three topics that I will be covering, I'm going to be doing quadratics, sinusoidal graphs and functions, graphing those, and doing sequences, series, and finance, that stuff. Boom. Okay. So for my first topic, quadratics, there's three main formulas that you would have to know. The standard form, which is useful for finding the y-intercept, which will be the c value here, and then the factor form, which is useful for finding the x-intercepts, aka or the zeros, which would be x minus r and x minus s here, and then the vertex form, which is useful for finding the y-axis, for finding the y and x value of the vertex, h being the x value and k being the y value. And then a good thing to know for each of these is that the standard form, you can go from standard form to factor form and standard form to vertex form, but you can't go vertex form to factor form. You would have to expand it into standard form first. So there are many types of kinds of factoring that you could do. The first one being common factor. So as you can see in our first equation here, xy plus y turns into equals y x plus 1. Because you can see the y previously was distributed to all the other stuff in this equation. So an important thing to note is that when factoring out the y doesn't just go away. It becomes a 1 because when you expand it back out, the y multiplies into the 1, creating another y. So for another example of this, we would have 4x squared plus 8x. And then we could comment factor out the 4 and the 8, leaving us with 4x, x plus 2. And then next, for the trinomials, you mainly want to find something that multiplies into the c value here, or multiplies into the 20, two variables that multiply into the 20, and then both of them adding up to 9. So as you can see here, since the coefficient for x is equal to 1, then you can just automatically know, you can just put in an x here, because there's no other coefficient, and then what multiplies to 20 and then adds to 9. That would be 5 and 4. And then as for the more complex trinomials, there are many different strategies to solving this equation. But for the one that I use, I go off to the sides and I find the multiples of the first coefficient and the multiples of the second one. So like 5 and 2. But I see this is negative here, meaning that I know that this 10 has to be two negatives to multiply into a positive, turning these both into negative. And then I do like a crisscross here, multiplying these two, giving me negative 4 and negative 5. And then I add them together, giving me negative 9. So leaving me with, and I just take the first number here and this one, and I just add like the x value to it. So it would be 2x minus 5, and then x minus 2. Because I can see the 1 here just leaves me with a coefficient of 1 at x, which I don't have to write. So since there are many different ways to factor trinomials, there are many more methods online, but I don't have the time to teach multiple more methods. So I just taught the one that I knew best, which sort of requires trial and error, but you get more used to it, and I feel like it gives you more of a sense of what factoring looks like, and lets you like get a sense of more of a pattern as you get more experience using it. And also a thing to note, do you see anything wrong with these equations? That's because you gotta remember to add this equals 0. See, all of these equations only work if they're equal to 0. And you gotta remember to keep the 0 consistently throughout your steps from the equation. Because this is this is a mistake found in a lot of beginners when factoring. And even in experienced people, they forget to add the zeros. And the reason why these have to be set to 0 is because you can only find the x-intercepts when y is equal to 0. See, on a parabola, you can see these points is when this line, y equals 0, is intersecting with the parabola, which is exactly why you must set these to 0. So now I'm going to go over a few more different factoring techniques that you would see. So the first one being difference of squares, which you will often see on many different problems. I will often like sneak itself in. So you could kind of identify this by saying a subtraction symbol and the first and second term being perfect squares. So here you would end up getting x plus 2 and x minus 2. Because the reason for this is because as you can see here, there's no b value. There's no like bx in the standard form. So the reason this happens is because let's expand it out. Because 0 equals x squared, oh sorry, I don't need a bracket here. X squared plus 2x minus 2x minus 4. So you see the two x's, they just subtract from each other. And you end up with just the first and last term. So as for this next example, you can also have a different squares within coefficient as well. So you would end up having 3x minus 3, 3x plus 3. Really similar, just with a coefficient. And then as for factoring by grouping, you want to factor this by finding like which. Sorry, I realized I made a mistake when writing the equation for this. But factoring by grouping is basically what you want to do is grouping two of the variables in the equation, and then common factoring something out of them, which leading you to use those two things that were common factor out of. So for example, eventually I'll end up with x plus 1, and say I common factor out like a 3 and a y. These two would end up as the new expression, and then these two expressions would kind of cancel out and turn into one expression. And this is what you would sort of end up with as like a visual. And as for the actual example, here I could group together like
and 3x squared plus 6. And the factoring by grouping is pretty flexible. So you can pick mostly any of the terms and you'll end up with the same thing. So here I factor out a 3, and here I factor out an x.
So as you can see, I end up with essentially the same thing, leading me to, don't forget equal signs, leading me to get 3 plus x, and then x squared plus 2. And then that would be how you would factor by grouping. As you would just take these two are the same, and then this one and this one you would just put together and create a new one. And then next, as for the perfect square trinomial, you can see this is the most basic example. And you can see that there's the middle term has 2ab, a squared and b squared. Mainly you want to look for the ends of these two to both be perfect squares. But another way that you can check is by doing the equation. And the way to check if it's a perfect square is if the middle term is half of the square root of the first term and the third term combined. So for example, the formula would be like, say this is our b value, the b over 2, and then since we don't want to see that as our b, we would see square root of a plus square root of b over 2. Or like, whichever variables like we want to use is equal to like the middle value, which here would be like 2ab. And then, so basically here we can just quickly factor it by taking the first and the third term, putting it in an expression, and then putting the square over it. Because then that's just a pattern that you see that will eventually end up being the middle term. So now for completing the square, the first step to completing the square is common factoring out the first and second term. So the common factor would be 2, but make sure not to keep that x here, because that's what we're going to use to factor it out in the end. Plus 10x plus 8. And now for completing the square part, we use the formula b over 2 squared. So we take the 10, and then we divide it by 2, and then square it, which would give us 25. And then now here we add plus and minus 25. Plus 10x plus 25. Make sure the plus 25 goes first, and then minus 25, because I think it's easier if you have the plus first. Plus 8. So now I only want these three terms to make a perfect square. So I would multiply this 2 to the negative 25 to get it outside of the equation, to get outside of this like brackets. So I'm left with y equals 2x squared plus 10x plus 25, and I multiply 2 by negative 25, gives me negative 50, and then I add negative 50 to the 8, which gives me negative 42. And then I just see this is a thing that we learned earlier, the perfect square trinomial, with the first and third term being perfect squares. X plus 5 squared minus 42. So with the 5 being the x value, and then negative 42 being the y value of the vertex. But now you want to see for the 5, it's actually a negative 5, because a good way to see it is that it's opposite. So it's actually, the coordinates would be negative 5, negative 42, and that would be where the vertex is. Now, a common mistake when expanding the vertex formula is expanding this, distributing this 2 into the x plus 5, But this is actually wrong, because you would actually have to FOIL it first, because first of all, it's BEDMAS, and then the second of all, when you FOIL, distribute this, that messes up the process of factoring and FOILing, because this, multiplying this first, causes you to have, look, when you have x plus 5 squared, if you distribute it first, 2x plus 10 squared, that would give you 2 brackets of 2x plus 10. Let me write it bigger. It would give you 2 brackets, 2x plus 5 squared, and then 2x plus 10 squared, and then it would just give you 2 brackets of 2x plus 10. When in reality, you don't have 2 brackets of 2x plus 10. You have 2 brackets of x plus 5, and then a 2 at the front. So you can choose to distribute. So you distribute this 2 at the end after you FOILed this into either one of them or into the final product of the standard form. Sorry for the handwriting, but so actually distributing this 2 into the FOIL at the start is actually the wrong move, because you would end up with 2 brackets of the wrong answer when you were only supposed to be left with 1 of the brackets being 2x plus 10. Instead, now you have 2. And also if you're trying to isolate for x, you don't have to like expand it and then factor it to get the roots for x-intercepts. You could instead just isolate for x here. And then let me show you how we would just isolate for x. Y equals 2, x plus 5 squared minus 42. So you would plus 42. Oh no, first you have to set it equal to 0. Sorry, you have to set it first equal to 0 in order to even look for the roots of what x is equal to. Because when you want to find the x-intercept, you plug in you sub in y equals 0, and when you want to find the y-intercept, you sub in x equals 0. So here we sub in y equals 0, so that we add 42, move that to the other side. That's 5
squared, divide it, and then gives us 21, x plus 5 squared, and then we square root this. Remember, it has to be plus minus, x plus 5, and then we subtract it. So plus minus square root of 21 plus 5 equals x. And then so this gives us two options, one where it's a positive and one where it's a negative, plus square root of 21 plus 5, or negative square root of 21 plus 5.
And that would give you the two different x values, or like the two different roots, x-intercepts, whatever you want to call them. Now this leads us to our final way of solving for x, which is the quadratic formula. This is mainly used when factoring is like extremely difficult, or like the numbers are too high, or or as like a last resort. And another tip that I would give for using this is when there's -4 and say c or a is a negative value, then that negative multiplies with the -4, creating it into a positive, which for me personally has messed me up a lot, as sometimes I multiply the negative, I multiply the negative with just a normal 4, not the -4. You kind of got to see like this part as like its own equation before you actually interact with the b squared. So this could change from a negative to a positive or stay a negative, depending on these other variables multiplying to it. And this part of the equation here is also important for the discriminants. So b squared minus 4ac can be either greater than 0, equal to 0, or less than 0. Now when it's greater than 0, that means that you have two real roots. And when it's equal to 0, you have one real root. And when it's less than 0, you have no roots. No roots. And basically what this tells you is that on a parabola, when it has two roots, it's like this, as you would normally see, intersecting at two parts. When it has one real root, it's intersecting, it intersects at one point. Pretend that intersects, but it touches the x-axis at one point. And then when it has no real roots, it's like in the air. It's not touching the x-axis. And then that's basically what the discriminants help you find to determine. So for our next unit, exploring the graphs of sinusoidal functions, this is the general formula for the different functions and transformations of these graphs. Starting with the amplitude, which can be seen as a vertical stretch, it can be found through subtracting the max and the min and then dividing it by 2. And it's also a key note to remember that the amplitude is always absolute value, meaning it's always positive. And then the next value is the k, which is like the stretch or the horizontal stretch of the graph found by the period divided by 360 degrees. This is also absolute value and can also be rewritten as period equals to k over 360 degrees. So you can kind of find both of them. And then as for a horizontal shift, which can be seen as the d value here, you can find the d sign. If there's normally you would see, for example, in the sine graph, you would find the closest point from your cosine, which would start from here, or your sine, which would start from here, and then find the amount of degrees that it was shifted by to the right. And then, but if there's not a clear point, you could use the formula d sine is equal to d cos plus 90 over k, absolute value, which would help you find which will help you be able to like find the exact point from the horizontal shift. And then as for the vertical shift, it's just simply max plus min over 2. So like 1 plus -1 divided by 2, which would be 0, starting at 0. And that would be your transformations for sinusoidal graphs. So as for the primary trig ratio, for the tan graph, we do not really cover it much in IB. But as for the sine and cosine graph, I sort of imagine it as like a wave, and I imagine the cosine graph as being in the middle of the wave, and as for the sine graph being at the start of the wave. And a lot of these have the really similar properties of being in a range of -1 to 1, with the tan graph having asymptotes at 90 degrees and 270 degrees. And the cosine graph intercepts at 90 degrees and 270 degrees, while the sine graph only intercepts at 180 degrees and 360 degrees. So here you can try finding the equation of a graph yourself. But sorry, the graph isn't very consistent throughout, because I was drawing it by hand. And also I want to note a mistake that a lot of people make. When drawing the sinusoidal wave when it's over the x-axis, people often mistaken this as the c value, or the vertical shift, or the d value, sorry, or vertical shift, when in reality it's the midline, such as here. When we found the d value, when we added the maximum and minimum and divided by 2, we got 0, which aligns with the midline here. And when we found the amplitude is basically the distance or range from the maximum point to the midline, or the minimum point to the midline. And as you can see here, we subtracted them, and then we subtracted the maximum and minimum, and then we got 4 over 2, and then we can see the distance from here and here, it's 2. And as for k value, 360 degrees over 180 degrees, we took the period of like the time that it repeats, which is 180, and then divided by a period of 360, and we got 2. And then there is no phase shift for the sine graph since it's already at the start of the wave. But for the cosine, when we want it to be at the start of the maximum, it would be at 45, because that's where the midpoint is of the first curve or wave of the sine graph. So we just add a subtract 45 there. So for this question, you can pause to read it. But the first thing that we did was we found the amplitude, and we're subtracting the maximum from the minimum and then dividing by 2, which we got equals to 2. It would have been negative, but you have to remember that amplitude is absolute value, meaning that it's always positive. And then as for the d value, we added the maximum and minimum together and divided by 2, which got us the midline. And as for k, earlier I made a mistake. I said it was period over 360 degrees, but it's actually the other way around. It's 360 degrees over the period. So I fixed that mistake, and we got 30 degrees. As for the c, got equals to 6, because since we want to find what time it is at the meters at 3 p.m. we had to, since we're using the cosine value, since cosine starts at the maximum, we had to add a negative at the front, turning cosine negative to flip it to allow us to find the minimum, and then we moved it to the right 6 to get to match it with the 6 a.m. and then we got this as our function, and then we used mapping rule. Remember the arrow, because a lot of people forget that, to show the transformations onto the new points. And then we ended up graphing it, and then we subbed in f of 15 because 15 is 12 hours after because 15 is 3 hours after 12 p.m. So we subbed in 15, and then we got up to the point where we have cos of 270 degrees, which we know is 0 based off the trig graph, and then we subbed 0 back in, where like it equals to 0, and then we got it's equal to 4 meters at 3 p.m. and that's basically how you do the word problem.
For the geometric and arithmetic series unit, I'm focusing mainly on the application problems because that's the part that I mainly depend on. So overall, I'm working on A2, C3, and D2.
So for this question here that you can try for yourself, this is a geometric unit, geometric series for finding the sum, because it asks us how much they climb after 30 days, and the amount that it keeps rising by is every 2, showing that it's addition, not multiplication. And then we just sub in the values into the formula, which is over here, and then we just solve for the amount of steps that they did after 30 days. So for this question that you can try for yourself, it is a geometric question because it asks us how much it multiplies after. It asks us after multiplying every hour, how many there are left after 24 hours, showing us that this is a geometric, and showing us that we need to find the common ratio instead of the common difference. The question before this, I said that it was geometric, but I meant that it was arithmetic, so that's my fault. And then for here, we use the formula UN to find the total number of bacteria. To find the amount of bacteria after 24 hours. But to find the total number of bacteria, we had to use the sum formula, which to find the total number of bacteria, which is 16 million. And lastly, this is the financial application question, which you can also do for yourself. These are some of the definitions of such as K is the number of compounding periods. You also should remember that R, when you sub in the interest rate, you know how normally it would be you would have to move the decimal over, and 4.2 turns into 0.042. You would just, in this case, you would just keep the interest rate exactly how it is because it's already divided by 100, so that does it for you. And another thing to note is that normally when dealing with money, you would round to 2 decimal places. In this case, I didn't have to, but that's something that you should keep in a reminder. So thanks for watching my guide on how to do the A2, D2, and C3, which focused on quadratics, solving application questions of series and arithmetic questions, and sinusoidal graphs. Hopefully this helped review, and it definitely helped me review, so thanks.